Hey guys, my name is Shriprat and welcome back to the Python for Beginners series. In this video, we'll be taking a look at how we can add data and behavior to the student objects that we've created in the previous video. And without any further ado, let's get right to it. Now this is what we did in the previous video. We created this class called a student, but we didn't really give it anything under it yet, right? And then we've created two student objects by using this syntax here, by saying s1, the variable name, equals student, the name of the class, and two brackets, right? And then we've just printed them out onto the console to see that both are in fact student objects, right? And both are present in separate locations in the memory. Now, what we want to do right now is try and see if we can give these students names, right? So that would be us putting some data into those objects, right? So the way in which we could do that is by simply saying s1.name equals Shriprat. So the name of s1 will be Shriprat, right? Now this is just an arbitrary name that I picked. You can call this variable anything you want again. Now this functions exactly like any other variable that we've worked with so far, right? So, and if we want to print this out, we would do something like print s1.name. Right? This is exactly how we would print it onto the screen. If I run this, we'll see that it prints Shriprat. Now, we can't just do print name and get away with it. That's because think of the student object as a box, right? So this student object s1 is a box, and when we just said s1.name equals Shriprat, right? So what we just did there was we created this variable called name, set its value to be equal to Shriprat, and put it inside this box s1. Now we can't really access the variable name yet because it's present inside this box, right? So we can't just do print name. What we would have to do is explicitly say print s1.name. We have to tell Python where to find that variable, right? So we do print s1.name and not print name. Now coming back to the code, let's try and printing s2.name, right? We get an error. Now this is because s2 does not really have this name attribute yet. And recall from the previous videos that an attribute is just another word for data which is associated with an object, right? So s2 does not have a name yet. So let's just create s2.name really quick, and let's give it something like example, right? Example. Now when we run this, it just prints example onto the screen and everything's great. But we've created this name variable outside of the student class, right? We really don't want to do that. We want to make use of this class template somehow, right? And in order to do that, we are going to use these curly brackets here. Remember how when we called functions, we used these brackets, and within them we pass some arguments to the function? Well, this is exactly the same, but in this case, when we create an object, a special function gets called, and that function is the init function. Now let's actually write this init function. This init function must be present within the class itself, so we can do def underscore underscore init underscore underscore and open and close brackets. Now this function must look exactly like how I typed it. It must have two underscores before, two underscores after, and the first parameter that it must take in is called self. Now this first parameter can be called anything. It can be called this, it can be called obj, it doesn't really matter. But according to convention, everyone just names it self, and it's a good idea to just stick with convention. I always just write self here. But what is this self really? I'm going to come back to that in just a second, alright? Now within this function, we can write any code that gets executed when we create this student object. So when we say s1 equals student, any code that's under this init method is called, right? And notice that I just used the word method instead of function. That's because this function is associated with the student class, right? And recall that functions associated with objects are called as methods, right? So let's just for now print student created, right? Just so we have an indication that this init method is running, right? Now let's get rid of all of this code right here and just run this much. Now you'll see that it prints student created twice. That's because the first time this function was called was when s1 was created, right? So this is actually the function call to this init state, init function, and this function call occurs when we create the second object s2, and again it prints student created the second time. Now what is this self keyword? What is it even doing there? Well, the way in which Python works is that when you actually create this object itself, or for any methods, the first parameter is always passed implicitly by Python itself, which is to say that Python itself automatically passes the first parameter into this function. Now what is this first parameter? This first parameter is the instance of the object itself. So when we are creating this student object, let's say s1, this self variable will be set to be equal to s1, right? So if we actually just say print self and run this, we'll get the exact same result as we had before when we did s1, when we printed s1 and when we printed s2, right? So what actually happens here is the first argument is s1 itself. So this is like passing s1 into the function like that, and passing s2 into the function like that. But the only difference is that this happens automatically and we are not supposed to pass them in explicitly, right? So that's what self keyword is. So instead of doing things like s1.name right here and setting it equal to some value, what we could just do is use the self keyword within this init state, init function, right? And do self dot name equals something, or let's just say test for now, and we can get rid of this code and run it again. Let's actually just print this self dot name, right? When we run it, we get test printing twice, but that's not what we want, right? We want a unique name for each and every student. So this is where we can start using this function by sending arguments into it, right? So now we can just say that the first argument, well actually the second argument, because the first argument is the instance itself, which is being passed implicitly. So the second argument which we want to pass into this init function, or into this init method I should say, will be the name. So let's say the first one will be Shriprad and the second one will be example again, right? So and let's make this function accept a parameter called name underscore, just so we can distinguish it from this name here, and we can just set it to be equal to name. Alright, now what happens here when this student is created is that this string Shriprad is passed in as the second parameter, which gets stored in this variable called name underscore, right? And then self.name is set to be equal to name underscore. This is exactly the same thing as doing s1.name equals Shriprad, right? So if we were doing it outside of this class, we would do it like s1.name equals Shriprad. But the advantage of doing it this way is that we just need to write this code once, right? And this code just runs for each and every student that's created. So now if we actually just go ahead and run this code, we will see that we get the exact same result as before when we tried creating the s1.name and s2.name variables manually. So now we know how we can create attributes within these objects, right? But what about methods, you ask? Well, methods are also done in the exact same way as we did the init method, right? So all we do is just come down here and create a method. Let's say study, because students study, right? Now this method should again take in an instance of the self, so that this method can access the instance on which it's operating, right? This will become clear in just a second. So let's create another variable or another attribute called, let's just call it score, right? And let's say that Shriprad on an average scores 85% in his exams. An example on an average scores 99% in all of their exams. Now example is a genius here. Now we can just set self dot score to be equal to score underscore, and the only reason I'm using underscore here right after these names is to just distinguish it from the actual variable name itself. It's not really necessary, like you can get rid of the underscores and it's still gonna work fine, but I just like using them because, well, I just like using them. Anyways, so this study function will not take in any other arguments. It just takes in the self parameter, and that's gonna be it. Now, why do we need this self parameter here within this study function? Well, let's say that we call s1.study. Alright, when we call s1.study, we want the score of the student 1 to increase, right? We don't want the score of student 2 to increase or any other students to increase. So that's why we need a reference to the current instance of the object on which we are calling the study function, so that we can do things like self.score plus equals 1. So this code right here just takes the self.score, which is the score of S1 in this case when we call study on S1, right? So it just takes the score and then adds 1 to it. Alright. Now if we didn't have self here, we would not have any way of accessing this student, right? Of accessing which student the study method is called on, right? So we can't do things like self.score plus equals 1. We would have to hard code it in by saying s1.score plus equals 1 or something like that, but that's not gonna work out because we want to be able to call this study function on multiple students, not just on student 1, right? So this function must take in the self parameter as well, and we are going to do self.score plus equals 1. And it's not like we can escape not being able to give a self parameter here, because Python automatically is going to give one argument into this function on its own, right? So if we don't have anything here, it's just going to throw an error at us saying that you're trying to give in one argument here, but the function expects 0 parameters. So there we go. That's why we use the self variable as a parameter in each and every method that we write. Now there are exceptions to this when sometimes you just want a method there to not reference any part of the student class, and in that case you can use something like static method decorator, but that's a topic for another video, right? In this video, let's just keep it simple and make every method accept a self keyword, a self parameter. Alright, so this code here, this function here just takes in self, right, and increases the score of the student by 1. Now when I actually call s1.study, let's print s1.score before s1 studies, and let's print s1.score after s1 studies. Right, now when I run this, you will see that it prints 85 before and then after he studies. So when we call this s1.study method, this s1 is passed in as self, and then self.score, which in this case is s1.score, is increased by 1. Then when we try printing s1.score, it prints 86, which has increased by 1 since he has studied once, right? If we call this study method twice, we are going to observe that the score increases by 2%, right? And these print statements are being executed because we have a print statement here within the init method, and we can just get rid of that for now. Now let's quickly try making student 2 study. So I'm just going to replace s1 with s2 here, and when we run this, we should get, we're still printing s1 score. Let's print student 2 score right here, before and after studying twice, right? Now in this case, we see that student 2 scores 99% before studying, but after studying twice, somehow he started scoring 101%, which is not really possible, right? So as an exercise for you guys, you can try and implement an if statement here, which checks for the score, and if it's exceeding 100, it just does not increase the score anymore. So that could be like a homework for you guys if you're watching this. And with that, we have reached the end of this video. A quick recap of what we did so far today. So first, we have seen how we can create the init method, which is kind of like a constructor, if you will, if you're coming from other languages, right? So this constructor, this init method gets called when a student object is being created, or really the init method of any class gets called when an object of that class is being created, right? And this method can take an arguments within the creation of the object itself, like so, right? But the first parameter passed in will always be the instance of the object itself, right? And this is something that Python does automatically for us. Then we've seen how to define our own methods, which are not special in the same sense as init is, right? And then we saw how we can define variables to be bound to certain objects. So in this case, we created a name object, a name variable and a score variable within the student object, right? So we did that, and we've just looked at how we can call methods, right, by using the dot operator right there, and how we can access variables by using the dot operator. And that's pretty much it for this video, guys. And in the next video, we'll actually be looking at some real world examples, I guess you could say, and compare object oriented programming with normal programming, right? Programming without using objects, and see what are the kind of advantages of object oriented programming and all that. So see you then, and until then, remember, anybody